Okay, hey. All right, I just did number 6 in the other video, so let's move on to 7. We only have 2 more to go. This will be a short one. This is part 2. Let's go. Number 7. It says classify the quadrilateral whose vertices are shown below. So we're going to do that. We're going to do it the same way we always do. We're going to build our little right triangles. We're going to find our slopes. We're going to find our lengths. That's literally all we ever do. So here goes. For AB, I see a rise of 2. I see a run of 5. So starting with slopes, I got AB with a rise of 2 and a run of 5. And that's it. I don't have to reduce it, anything like that. I would now like to do BC, I suppose. So technically I'm going from C up to B. So I'm rising 1, 2, 3, 4, 5. And I'm running 1, 2. So I'm rising 5, running 2. That's it. Don't have to reduce. Let's go from C to D. I'm running 1, 2, 3, 4, 5. I'm rising 1, 2. Yeah, CD, sure. Rise 2, run 5. Alright, couple things just happened. Something happened a second ago, actually. When I had the 2/5 and the 5/2, I noticed that those were reciprocals, but they're not opposite reciprocals, so I can pretty happily mark that this angle here, angle B, it is not a right angle, right? So on our little list of options, we are not a rectangle or a square. I should probably keep this handy. If not this whole flow chart, let's at least keep every option handy. It's kind of useful to use process of elimination as you go, right? Clipboard. Paste. So here's a list of all our options. And even just by finding the first 2 slopes, I'm already ready to say that I don't have a right angle, so I'm not a rectangle or a square. Now that I've found my 3rd slope, I see that it is the same as AB. So I now know that AB and CD are parallel, which means I can't be a kite and I'm not a plain old quadrilateral anymore. Having one pair makes me at least a trapezoid, right? So now let's do the one last side. Red, orange, haven't done orange. It's DA. So you can see that I'm running 2 and I'm rising 5 again. So for AD, our rise is 5, our run is 2. That means that we do have a second pair of parallel sides. These guys are parallel. So we're officially not a trapezoid, which means we can't be an isosceles trapezoid, which means we're now either a parallelogram or a rhombus. And so kind of just like one of the examples we did a minute ago, was it the last one? It was. I don't really need to find all of the lengths, right? Because I feel like this thing's a rhombus, but if I just show that the sides next to each other are the same, then we already know the ones across from each other are going to be the same. So let's just find the length of AB. And then don't find the length of CD. You know that'll be the same because opposite sides are always the same in parallelograms. Just find BC. Because if AB and BC are the same, then we've got to have them all the same and we're a rhombus. So there's a bit of a shortcut you could take here. I should be saying the measure of AB and the measure of BC. So AB is what? 2 by 5? So it's 2 squared and a 5 squared. That's a 4 and a 25. That's root 29. And the other one is, of course, the same because it's 5 and 2 again. So it's 2 squared, 5 squared. So that's it. I know this is root 29, and then because the sides are all parallel, you can rest assured that this one's root 29 as well. Then we did the math to find BC, and it was root 29. And because we're parallel, you know this is root 29. So that proves it. They're all the same. So we're not a parallelogram, we're a rhombus. And we'll say it's a rhombus because it has 2 pairs of parallel sides. And all four sides are the same. Oops, hold on. Messed up my pen. All four sides are congruent, really is what I meant to say. And then technically you should say, but it doesn't have right angles. And saying that it doesn't have right angles is just your way of saying that it is not a square, because technically square would be a better answer than rhombus. So you shouldn't just leave it at a rhombus in case it's a square. So you have to prove that it's not a square as part of your explanation. But that's it. Took us 6 minutes to do that one, so let's do 8. Should take us 6 more minutes, then we're done. Although looking at this thing, certainly looks like a kite. Dang it. Dang it. All right. There'll probably be a question on the quiz where you have to plot your own points, which shouldn't be, a problem for most of y'all. You guys are fine at plotting points, but just in case, to plot a point, 3, 0, we're going to go 3 to the right, but not up or down at all. So it'll be that point there. Remember to label it. That's A. Then 8, 2 means go over to 8 and up 2. So that's B. Then C is 10, negative 3, so go 10 to the right, but 3 down. So that's C. Then D is at 2, negative 12, so it's way down here. That's point D. So this thing definitely still looks like a kite. To prove that it's a kite, would have to show that the adjacent sides are congruent. So technically, if you know your definitions really, really well, for this problem, you could skip the slopes. Because as soon as you show that you've got your 2 pairs of congruent sides, you're done. That would prove that we are a kite. So we could skip the slopes if we wanted to. I don't think I'm gonna. I think I'm gonna do it anyway. So here I go. Let's start with AB, like usual. So I see rise 2, run 5. Yeah. So same slope as the last problem, I think, right? But slope, AB. I see the rise of 2, I see the run of 5, so it's 2/5. No work really necessary beyond that. Then for BC, I see a run of 2 and a rise that's going down 5. So that's a rise of negative 5 and a run of 2, so that's negative 5 over 2. So you might notice something here. You might notice that those are opposite reciprocals, and that does give us a right angle. But that doesn't really matter. Kites can have right angles sometimes, but it doesn't, it's not a rectangle, it's not a square. So this right angle is just kind of a coincidence. But it's interesting to see, I guess, that technically those sides are perpendicular. It just doesn't really matter here. Next. CD. Alright, we're dropping down a bunch, we're running over a bunch. So let's actually imagine going D to C. So D is at 2, we're going 2 to 10, so we're running 8. We're rising from 12 up to 3, so that's a change of 9. So the slope of CD is a rise of 9, run of 8. And that can't be reduced, so you're done. And then finally AD. To get from D all the way up to A, we're rising 12 units, and we're running only 1 unit. So it's a rise of 12, run of 1, which is just 12. So there's all your slopes, and none of them are the same, so nobody's parallel. So again, if we went back to that little flowchart of ours, that alone tells us that the only thing we could be is a kite or a plain old quadrilateral, because we'd be here with no pairs of parallel sides. The only options for us are kite or quadrilateral. And if none of our sides are congruent or whatever, then we'd be just a plain old quadrilateral. But I think we are about to see that the two sides next to each other are the same, and then the other two sides that are next to each other are the same, and that makes us a kite because we'll have those adjacent sides that are congruent. So let's do that math. Then we'll be done. All right, so I think the green ones are kind of obvious. You've got 2 and 5 and 2 and 5. So of course when you go to do that math, the measure of AB is going to be the square root of a 2 squared and a 5 squared. The measure of BC is going to be the square root of a 2 squared and a negative 5 squared, technically. But guess what? That's a 4 and a 29. This is a 4 and a 29. What's wrong with me? Guess what 5 squared actually is? 25. My brain got ahead of me because the final answer is root 29. And of course another 4 and 25 is going to make another root 29. So these two short sides pretty obviously are the same. They're both 2 by 5. Now down here, the longer blue ones, I pointed this out in class. I remember doing this. But here, you might see the 1 and the 12, and then an 8 and a 9, and think that those are going to come out different, right? But do the math and you'll find out that they do come out to be the same. So make sure you actually do the math to double check. But the measure of CD will be the square root of the 8 and the 9 squared and added together. So that's a 64 and an 81, which is a 145, or the square root of 145. Now the measure of 80 looks like it might be different because it's a 12 squared plus a 1 squared. But the math actually comes out to be a 144 plus a 1, which is 145. So don't get tricked by that, because it does turn out these two sides are the same as well. So we do fit that definition of a kite. And you'll say, you don't have to mention the slopes at all. You don't have to mention that the sides aren't parallel. You can say it if you want to. But all you have to say to be a kite is, it's a kite because it has two pairs of adjacent sides that are congruent. And that's it. All right, I hope that helps. Don't forget, on the day of the test, I'm going to be giving you not this flowchart. I will not be giving you this flowchart, but I will give you this grid. Okay, so you'll have the definitions of all the quadrilaterals. That'll be really very useful, I would think. So hopefully this quiz will go well for you guys, and it'll help you raise your grades if you need to raise your grades, or it'll help you keep your grades high if they're already high. Anyway, thanks for watching. See you in class. Goodbye. Watch this. I'm going to fade to black. Whoa.